Algebra I 6.9 Equations, Factoring, and Word Problems. When we solve word problems, we look for clue words to tell us which operation signs to use or how to write the equation. And we need to understand the problem and figure out what it's asking of us. We need to make and carry out a plan and find what strategy we should use. And after we find the answer, we need to check it to make sure our solution makes sense. So here's some clue words. If it says twice a number, well, we can make the number x, and that would be 2x. It would be twice the number. And we know if it says product, that's multiply, difference is subtract, sum would be addition, wouldn't it? Square of a number, if x is the number, it would be x squared. And if it even says something like a number times 1 less than a number, break it into just a few of these. A number times, okay, so that's x times, so we'll put x and then a parentheses, 1 less, all right, so it's going to be minus 1, the number. So it's going to be x times x minus 1, see? Just break it into smaller pieces. 1 more than twice the square of a number. That sounds confusing, right? 1 more than, okay, so it's plus 1, twice the square of a number. Well, the square of a number would be x squared, and if we're going to do twice that, it's going to be 2x squared, see? So break it into smaller little pieces. 1 more than would be one part. See how we did that? Twice, that would be another part, and square of a number would be another part. So we can break this statement into 3 pieces to come up with that, see? We can translate the words into an equation and solve. The product of 1 more than a number and 1 less than a number is 8. All right, well, it's going to equal 8, isn't it? So let's let x be the unknown number. And it said the product, so we know we're going to multiply a couple of things together. So the product of 1 more than a number would be x plus 1, and 1 less than a number would be x minus 1, and it's going to equal 8. We can FOIL this. We get x squared minus x plus x minus 1, and these cancel each other out, don't they? So we get x squared minus 1, and it's going to equal 8. So to set it to equal 0, we use the property of equality and subtract 8 from each side. And when we combine like terms, we get x squared minus 9, because minus 1 minus 8, see? And it's set to equal 0. We factor this, so we know from this x squared we're going to have 2 parentheses. We're going to stick an x in the front for that x squared. And what can equal a negative 9? A negative 3 and a positive 3. And we set it to equal 0. And using the property of equality, we add 3 to each side of this one to get x equals 3, and we subtract 3 from each side of this one to get x equals minus 3, see? And it eliminates that. Now, using the principle of zero products, we've got it down to x equals 3 and x equals minus 3, and we plug that back into the equation and to see if it works, and yes, it fits. 3 and negative 3 fit. So that's a solution, okay? See? 9, and then that makes a 0 pair in the center when we FOIL it, and minus 1 is 8, see? The square of a number minus twice the number is 48. So, all right, let's let x be that unknown number. So we've got the square of a number, so that's x squared, minus twice the number, that's 2x, is 48 is equals 48. Let's set it to equal 0. So let's subtract 48 from each side. Now we've got x squared minus 2x minus 48 equals 0. We factor this. We find 2 numbers that the product is negative 48 and their sum is negative 2. And we get negative 8 and positive 6. We break them apart, and we can solve them with properties of equality, adding 8 to each side and subtracting 6 from each side. We get x equals 8, x equals minus 6. We can plug these back into this equation and see if it works, and check to see if the roots fit. Those are the solutions that make the polynomial equal 0. We just plug them back in, and they do work. I'm trying to save room on the dry erase board because I've got all this to write. So sometimes we need to reword before we can translate into an equation. Like the width of a rectangular rug is 2 feet less than its length. The area of the rug is 15 feet squared. Find the length and width. Well, in these other ones, we literally wrote what it said. The product of 1 more, see? And even this one, the square of a number, x squared. Well, this one is not really telling us how to write the equation. So we have to use our heads. We need to find the area of a rug, don't we? And length times width is the area of a rectangle. It's a rectangular rug. So we know we've got to do length times width. Well, it says that the width is 2 feet less than the length. So if we let x equal the length, then the width is x minus 2. And that means the length is x. So we've got x times x minus 2. See? We subtract 15 from each side so we can set it to equal 0. And to factor it, we need to find two numbers that have the product of negative 15 and negative 2. And we come up with positive 3 and negative 5. We split them apart, use properties of equality to solve it so it says x equals minus 3, x equals 5. And a rug can't be negative 3 feet, can it? So negative 3 is the 2 feet less than the length part. So when we plug it in, we get that the length is 5 and the width is 5 minus 2. See? So remember, we can't have a negative length. We can't have a negative distance. We can't have a negative speed. A car can't go negative 60 miles an hour. Even if it's going in reverse, it's still going 60 miles an hour. It's just facing the other direction. And we can't have negative time either, okay? So it said negative 3, but that really wasn't the solution, was it? Sometimes a problem can have more than one solution. And even though an equation is correct, all the solutions may not be correct. They may not be the exact answer. They may help us find the answer. So remember not to take it absolutely and assume that that's the answer. You got to think, and after you check it, figure out if the solution makes sense, okay? All right. We are all done with polynomials and trinomials and all of that. We're going to be moving on to chapter 7 now, and we're going to be talking about graphing ordered pairs and plotting points on a coordinate plane. If you want to get a review of the principle of zero products and how I set this to 0 and how I solved this, there'll be a link in this description. And all the links to factoring that I think are important will be in this description. And in the book, there is a problem that you need to find consecutive integers for this chapter and for the chapter review. So I thought I'd throw in a link to finding consecutive integers if you don't remember how to do that, okay? So that'll be in this description. Okay, we're going to be moving on to working on coordinate planes. And I'll see you there. Bye.